key
Water
concept.
example: molecular formula H₃O. Empirical formula H₃O, already in the simplest whole number ratio. So both formulas are the same. In this table, comparison between empirical and molecular formula is shown.
Key concept:
Empirical formula does not show the actual number of atoms. Different compounds can share the same empirical formula. Benzene C₃H₈, acetylene C₂H₂. Both have empirical formula CH. Give two examples of compounds which have the same empirical and molecular formulas. Think about small molecules already in their simplest ratio, for example, water and ammonia. Stoichiometry in everyday life. Stoichiometric calculations are essential for formulating chemical products like shampoos, perfumes, soaps, fertilizers. The chemical industry relies entirely on stoichiometry. This table shows different atoms and their ions. Chemical formulas of compounds. Empirical formula is simplest whole number ratio of atoms. Molecular formula is found using molecular formula equals n multiply by empirical formula, where n equals molar mass or empirical formula mass. If n equals 1, then molecular formula equals empirical formula. Example, find the molecular formula when empirical formula equals CH, molecular mass equals 78 grams per mole. Practice questions. The empirical formula is CH subscript 2O, molar mass is 180 grams per mole. Determine its molecular formula. The empirical formula is CH2O, molar mass is 60 grams per mole. Determine its molecular formula. Deduce the molecular formula from structural formula. To find the molecular formula from the structural formula, draw the structural formula. Count the number of atoms of each type. Write the symbols of all elements. Write the total number of atoms of each kind as a subscript. Remove the subscript one. Examples: structural to molecular formula. In acetic acid structure, there are 2 carbon, 4 hydrogen and 2 oxygen. Its molecular formula is C₃H₈O2. Can you find the molecular formula of phosphoric acid? Structure of n-Propyl alcohol and calcium carbonate is given. Determine their molecular formulas. Avogadro's number. In chemical reactions, huge numbers of atoms per molecules react. To work with these practically, we convert atomic mass units to grams. This conversion uses the concept of Avogadro's number introduced by Italian scientist Amedeo Avogadro. Scaling up in stoichiometry. Individual atoms' molecules are too small to measure directly. We scale up to large numbers of particles. In this reaction, 2 times 100 atoms plus 100 molecules equals 2 times 100 molecules. 2 times 10,000 atoms plus 10,000 molecules equals 2 times 10,000 molecules. Scaling up doesn't change the reaction ratio, just makes calculation easier. Enter Avogadro's number. To make mass calculations manageable, we use two C plus O 2 to 2 CO 2 times 6.022 times 10 to the 23rd atoms plus 6.022 times 10 to the 23rd molecules to 2 times 6.022 times 10 to the 23rd molecules. Why 6.022 times 10 to the 23rd power? Because 1 gram equals 6.022 times 10 to the 23rd atomic mass units.